amount in mole of a gas, you can do stoichiometry with gases. Okay, because quite often a reaction occurs which will produce gases, and we collect the gas, we measure the volume, and therefore we can find the amount in mole. Okay, and we can nice and easily use that molar volume equation, or we can use the ideal gas equation. Either one. If it's SLC, then your preference is to use molar volume because it is simpler, which means there's less opportunities for you to make a silly mistake. Okay. Once we convert it into mole, we use the molar ratio just as you would when you were doing mass stoichiometry back in year 11, just as you would have done when you were doing, say, titrations, all that kind of thing. So for example, if we want to know how much hydrogen gas is produced at SLC by reacting 27 grams of aluminium with excess hydrochloric acid. First thing you do for any stoichiometry, doesn't matter what kind of thing you're doing, you make sure you've got a balanced equation. If you're lucky, it's given to you. If you're not, then you've got to make it yourself. We know that from our mass, we're going to be able to find the amount in mole using the mass over the molar mass. Okay, so we've got our amount in mole of aluminium. We look at our equation, and we're doing what we want, which is hydrogen, over what we've got, which is aluminium. So we times our amount in mole by 3/2. Okay? Which gives us 1.5 moles of hydrogen gas being produced. We are then going to convert that into a volume of gas. It's at SLC, so we're timesing it by 24.8, we're timesing it by our molar volume, which gives us 37 litres to 2 sig figs. Okay. The other thing that we can do is volume-volume stoichiometry. Now, this is really quite easy, but it's a trick that you've got to remember. Okay, we know that the volume of any gas, as long as the conditions stay the same, will be the same volume. So if I got 3 moles of gas on one side of the equation and 3 moles of gas on the other side of the equation, then the volume of gas at the start and the end should be the same. If I've got 3 moles at the start and 6 moles at the end, then my total volume of gas should double. Okay? And we can do that. We can increase the amount in moles of gas in total because you might have one bigger gas with more molecules in it that breaks down to make 2 smaller gases, for instance. Okay? So, for instance, if we wanted to know what volume of oxygen should be used to fully react 1.5 litres of hydrogen gas to make water, we start with our balanced equation. Okay? Now, we are not going to convert this into moles because we don't need to, because we can use the volume ratio the same as we would use a molar ratio. Because all we'd be doing if we were converting was dividing them by 24.8 and then multiplying by 24.8. Yeah? So we're not going to bother. So 2 moles of hydrogen gas needs 1 mole of oxygen. So 1.5 litres of hydrogen gas would need 0.75 litres of oxygen. Okay? That 2-to-1 ratio that we can use for moles, we're using it directly with our volume. And that's it. Okay? It's nice and simple. You'll see some more complex examples of this, but the basic principle is the same. You use the ratios exactly as you would use moles. So you use the volumes exactly as you would use moles.